Alright. I've decided I wanted to I want to create an unscripted, unedited thought process on my theory of the universe. Now, this is more of a fun thought experiment, more than something to necessarily take seriously. But there's been a growing concern, an issue I've had, looking at the accepted explanations for certain things with the universe. So, I decided one day I would create my own theory. Just a fun little theory, base it lightly off of deals that I don't really fully agree with. Here we go. What if the universe is a snow globe? And every so often, all the matter condenses at the bottom, spread out, until a button is pressed, which shoots everything back out again. This would cause the swirling masses to hit each other, just like the Big Bang suggests. Everything would fly upwards or sideways, however this thing would be directed. And then, when everything hits the top, instead of it just slamming into it, because of the way of fluid dynamics, it flows around the curvature of the outside. And eventually it swirls all back and falls back into place. Now, I want to cover, real quick, the redshift. If, in a snow globe, our universe, we are falling, the ones closest to the bottom would be more affected by whatever kind of gravity brings everything to the bottom. So all the galaxies that are ahead of us, or below us, if you will, are moving faster, while we are moving faster than anything behind us or above us, as it were. This would explain why so many galaxies seem to be red-shifted, with only a few blue-shifted. Redshift, for those who don't understand, is based off of the Doppler effect. When a car is zooming towards you, it sounds higher pitched. This is a blue shift, because when something is coming closer to you, it will shift towards the blue light spectrum. And then as soon as that car passes you, it sounds to be lower and gets lower, as if lower energy. And this is redshift, because red light has the lower energy. And as a result, when something is moving away from you, its light also becomes closer to red. Alright, so this could potentially explain that. Having a curvature of the universe, even if we're not in that particular phase, could also indicate redshift if we're coming close to the edge of the barrier. Because when the other objects get close to the edge, they veer and curve around, not necessarily accelerating, but to our eyes, it would seem as if they are moving further away. Now, the next issue that I have is the idea that we have this law of conservation, where within a closed system, nothing can be created nor destroyed. So, then we also consider that all energy, since it is not destroyed, must transform into other forms. Where would the energy be coming from to expand our universe, and not just expand it, but to accelerate all of the mass within it? That would take nearly infinitesimal amounts of energy. This does not make sense. Sure, if it's not a closed system, it could make sense. But from everything that we have observed so far, this does not make sense. Where is this infinite energy coming from? Sure, you could say the dark matter is pushing everything, but that would take such an enormous amount of dark matter to be flowing into our system. So then I bring to you the next issue that I have. Systems are always flowing from high pressure to low pressure. So, if there is so much dark matter that is flowing into our universe, that it is causing everything to accelerate, why would not one side be accelerating towards us, the side that is closer to the intake of pressure? What I mean by this is, if you've ever filled, let's say our universe is a hose, and you turn on the water. Within this system, the water behind us will be moving faster than the water ahead of us, simply because that's where the pressure is. It would be pushing us. So we would have neighbors behind us who are all moving towards us, so we would get more blue shifts. Alright, so high pressure to low pressure. This explanation also does not work. Alright, now the next thing that I want to go ahead and discuss is going deep into a pattern that I've noticed within every stage of physics, from the subatomic level to cellular level to planetary level, galactic level, and I want to compare how these systems seem to interact in such a way that there's a clear pattern that's repeating. Okay, So from what I understand, which, albeit I have not researched in depth on every aspect of this, I've just done enough to see what I need to see that things aren't lining up with the current explanations. So, quarks. Quarks are one of the fundamental particles of the universe. It is said that they seem to randomly appear and disappear. But I don't think it's actually that random. I think there is a system to the randomness. But we'll get into that later. For now, quarks pop in and out of existence based on their various charges and directions. They have 6 different states based on their trajectory, and this causes their behavior to change. If conditions are right, they will form into protons and neutrons. Okay, something I want to go ahead and point out. Quarks, while probably not spherical, maybe more of a dot, although different sources say differently. Some say that they're just flat, some say they could be spherical. Point is spherical. And I would say, what if they're morphing based on their motion and their spin, much like a rubber ball filled with liquid that is spinning very fast. The equator line gets pushed out, or if there's other pressures involved, you can squish it together here and there and everywhere. Alright. Bosons. Bosons are integer spins, or full integer spins. Not balls, but it's more of like energy, I think. But when you combine these two fundamental particles, along with a few others, and you take into account the three major forces that we have identified, which is the strong or weak force, the gravitational force, and the electromagnetic force, which I'll talk about more later. The electromagnetic force, combined with these other two forces, are what bring these fundamental particles together to create the atoms, from the protons, the neutrons, and then you have electrons. Atoms are also spherical, which seem to change behavior by a system of consistency based on the number of protons existent. So, consistency, that's interesting. Let's go ahead and cover the electromagnetic force real quick. We've been finding, and by we I mean mathematicians, physicists, have been finding that when doing calculations, there is this number that keeps popping up, which is roughly 1 over 137. It's called the fine structure constant. What is this? Well, it's a number that shows up when all units of measure cancel each other out. A number that just exists within our universe. And this number handles the electromagnetic force like it's just a number, kind of almost like in a computer, where you have a constant number to represent the base values of either your player stats or the world physics. We'll just hold on to that for now, and we'll continue on. Alright. So atoms are, again, spherical. They're not perfect spheres. They seem to morph a little bit here and there based on their, their motion, their spin, rotation, the pressures around them. But overall, they do appear to be kind of spherical. Electrons also. Another interesting thing about electrons and atoms, really, is that there's a charge. So, when an electron gains energy, it moves to another level of energy that circles, well, not really circles, but like goes around the nucleus of the atom. Based on the amount of energy, if it's low, the electron will be closer to the atom, like mercury. And if it's high, it will be far from the atom, kind of like Pluto. However, this is not a very great comparison for this, because I'm not so sure that planets holding energy is the basis of how far they are from the sun. But who knows? Maybe there is some correlation there. How much mass and how fast they are may play a part. Anyway, next. So we've determined that the fundamental particles of the universe are at least somewhat spherical, based on motion, based on rotation, and then there's pressure that can be involved, and charge. Molecules, molecules are not spherical. They seem to lock in kind of random-ish ways. Not really random, but like they lock in asymmetrical ways. It's like they're building onto each other, but they can only hold onto each other at different angles depending on what kind of elements and so on. Which we'll still cover later, if I don't forget. After all, this is unscripted. If I scripted this, I could do so much better, but I don't want to do that right now. Maybe someday. For now, though, molecules bind to each other at different spots based on their element, and how those atoms are arranged. The physics property of, well, whatever amount of protons they have. Right, I do want to cover this, though, real quick. Isotopes. So, an atom has the same number of protons and neutrons in most cases. However, in some cases, generally by smashing them together at high speeds, like in the Hadron Collider, we get atoms that have irregular numbers of neutrons to the protons. For instance, gold isotope 198 Now, the normal is gold 197. But gold 198 has one extra neutron, but it's unstable. This particular isotope is actually poisonous to humans. Don't consume it. You will not enjoy that. But because it has an extra neutron, this neutron can't stay stable. And so the atom releases extra the atom releases this extra energy, this extra neutron, via radiation to expel it until it can stabilize to gold 197. Now, on the flip side, what happens if we have one less neutron and we have gold 196? Well, in that case, it's also not stable. And yet again, it releases this energy, this extra energy, until it becomes a stable platinum 196. Yeah. So it seems as though all these atoms are looking for a stable environment to become spherical, but they hold their energy, instead of it being fully entropy, they hold at a stable position based on how much energy is currently inside. Alright. We'll cover platinum isotope real quick as well. Now, platinum isotope 197 seems to be stable, if what I read is correct, and it can have some uses. It, unlike the gold 198 that has one more neutron, does not expel extra energy to stabilize. And platinum 196 is also stable, which is interesting. Alright, let us continue. So molecules lock asymmetrically. And then these molecules form non-living matter and living matter, which is all bound by the mechanics that are dictated or follow the rules that are set. How are these rules set? Well, I want to go ahead and go back a little bit to the fundamental particles. I brought up the electromagnetic force, fine structure constant. But I also want to bring up this interesting observation. When I was researching this, just to expand my theory a little further, from the snow globe into what I'm going to build into, is quarks are half spins, while, as I mentioned, the bosons are full integer spins. A half spin kind of correlates with float numbers in programming, while bosons, being integers, integer spins, like integer numbers in programming. Yeah, in programming, there's variables that you can call. One of them is a constant. This is something that does not change. It just doesn't change. No matter what you do, it remains the same. And then you have your floats, which are numbers between integers. These are often used to dictate physics, movement, direction, vectors, anything that is not just counting. And then integers are used to hold just whole numbers by themselves. And then you have booleans, which are true-false statements. Basically, it just, is this true, is this false? Is it on, is it off? And since quarks do not always form into atoms, it seems like the conditions have to be met in order to do this action. It's very much like programming. For now, though, that's the deepest I'm going to go on that level. Alright, let's continue. So, molecules create structures that are asymmetrical because they themselves are asymmetrical. And there's not enough force pulling them together to make them spherical. However, there are more forces that can push against them, more pressures that cause them to take other shapes. At some point, though, we get cells. And cells are interesting because a lot of them seem to have at least a spherical starting point. Yeah, you'll get a lot of elongated ones that seem to have flattened, probably from pressure. You'll get, mostly just that, actually. Most of them are just flattened based on that. The other thing is their molecular structure. So the other thing that takes into account their overall shape is not just the pressures around them, but also their internal structure, what their molecules have formed, and how well that holds their insides and their membrane together. Now, they don't have nearly as many molecules going in to hold their structure, so I would argue that while many of them start off spherical at the singular cell level, as you add more cells, they become kind of like molecules. They're just connecting together at different points, but the pressures do not force them to be symmetrical, just mostly symmetrical, morphing their shape. These multi-cells become organisms, or organs, which become organisms, all of which can be relatively symmetrical, but usually just are not symmetrical. And pressures around them determine a lot of their shape, but also their DNA. The DNA seems to also be a code, because what you put in, you get out. But there's a lot more rules to it than that. Like, sure, there's 4 proteins that combine in different ways, but depending on how these are arranged, can completely change how something behaves. Much like the number of protons in an atom. And it seems to be like the constant force which drives the behaviors of atoms, where atoms are very consistent on behavior based on protons, with slight variations to those behaviors based on spin, movement, charge. Cells with DNA, and organisms with DNA also seem to follow that same principle. Because different sets of DNA can overwrite other sets of DNA or nullify whatever effect they would have, or add on to it in a very interesting way. Yet again, a code, something that seems constant for some reason, but we're gonna go on. So non-living things like rocks are also asymmetrical up to a point. And this is where the gravitational force comes into play. If there is enough mass, it will pull the molecules inwards to become more spherical. So we went from a stage of spherical beginnings to asymmetrical locking, back into spherical. Alright. So we have these big, giant masses of rock. You have your moons, you have your large asteroids really first, and those ones are less spherical. And then you have your moons, which are more spherical. And of course, well, Earth shows that you can have a spherical, non-spherical object. After all, we have giant mountains that protrude, and then we have giant depths that the sea covers, but the water makes it closer to spherical. But that's not what really makes this spherical. What makes it spherical is that, well, the atmosphere surrounds it in a sphere. The water level seems to be surrounded in a sphere. So, point is, as you grow more mass, the more spherical it becomes. And then, here's something that a lot of people I've talked with haven't realized, and I didn't realize it until I was researching for world building. The world is not a perfect sphere. The distance around the equator is longer than the distance around the poles. Because of the spinning motion that what causes the days, the spinning motion, the rotation of the planet itself. Just like the rubber ball filled with liquid spinning at a high speed, the equatorial lines are being pushed out. And to fill the space, because of the forces of liquid dynamics and centrifugal force and high pressure to low pressure, filling in the gaps, etc., etc., the top and bottom of the planet is smushed inwards a little. Even with all the rocks that are in the mountains that are still allowed to protrude, this squishes at the top and bottom. It's not entirely spherical. It's not entirely spherical. And its shape, yet again, is morphed largely by its motion and spin. Alright, the sun also is not fully or perfectly spherical. Its top and bottom is also squished a little. And these objects pull on each other. So a moon will get caught in the gravitational pull of a planet, a sun. Pretty much anything smaller will go around something bigger, depending on how much bigger, how much more mass it has. Which, of course, density of the materials comes into play for this mass. But we'll not cover that detail. That goes into a big rabbit hole that I don't care to go into at the moment. So, interestingly, the planets go around the sun much the same way as electrons around its atom. And perhaps if you were to add energy into a planet's movement, it would seem to go to another energy level that circles farther away from the sun. But if you take away some of its energy, it will get closer to the center, just like an electron. Interesting things here. Most of our planets spin the same way. However, Venus and Uranus spin backwards. This could hint at having been hit in a way that caused them to change course. Something to keep in mind for later. What's really interesting is recently I found that our solar system basically creates a bubble in space as well, based upon the sun's gravitational pull and its energy. There, on the outer edges, there are loads of smaller rocks that are rotating around it in every direction, forming a sort of shell. A loose shell, I suppose. Kind of like a cell, kind of like an atom. Now, a lot of our planets stick to the horizontal plane as we know it, but I think that's just because that's where most of the energy swirling around goes, because again, as the object spins, its outer edges flat, or its top and bottom flattens, so more mass goes to the center into a more like disc shape than ball shape, and as such more of the disruption occurs on this level, so more objects are going to end up following this. But because of the magnetic pull and gravity's, well, it's interesting. There's loads of objects that are just going around the sun in literally every direction. Like literally going around the poles, going around diagonally at every angle. Yeah, anyway. Point is, our sun gives us a safe bubble from the outside radiation, which is a lot. That is very prominent between our solar system and any solar system around us. So it's like our solar system is one of many bubbles moving around this large object. So, next, we'll get into the galaxy. the Milky Way. Our solar system is also spinning around the Milky Way. Yeah, that's right. So there's yet again, at this next level of matter, there is more rotation. And the Milky Way is rotating around its center. Yeah. So, an interesting thing. Most galaxies, or a very large chunk of galaxies, are all rotating and spinning in the same way. Now, some of them are not. Some of them, you can conclude that they have changed their rotation, very likely due to collisions that have occurred to cause a shift, just like Venus and Uranus. So, yeah. But what I want to go ahead and bring up here is our galaxy, the Milky Way, and all the other galaxies also seem to form a spherical shape. But also, like all of the rest of things, this shape is morphed and flattened down, for the most part, due to movement and spin. Again, like the rubber ball filled with liquid being spun really fast. But just like the solar system, there are forces unseen and many things that are not seen where it's clear to the right spectrum of light and so on that you can find that, just like our solar system, it ends up forming a spherical shape, which could be a bubble. I haven't seen anyone have a diagram of galaxies in a bubble. I have for the solar system, because it clearly makes a shell of objects floating around, but we don't have that yet for galaxies. But I would be willing to bet that we will eventually be able to prove that galaxies form bubbles of their own. So, let's bring this on to the next part. Not only do galaxies spin, but next we have clusters of galaxies. Now, clusters of galaxies are not nearly as spherical. They interlock in kind of weird ways. But this brings us back to another repeating pattern, where we have our fundamental particles are spherical. The building blocks atop of that is not spherical. You have your atoms that are spherical, molecules that are not, cells that are spherical but with a lot more conditions, and then multicellular that is not spherical. And then you have your solar system and galaxy that is spherical, but clusters and superclusters are not spherical. However, they still seem to form a loose bubble, kind of, but they're rotating around each other in weird ways, and that's why they kind of stick together in these clusters. But it's the same pattern, and they're also rotating around each other very slowly. Well, I suppose you could say technically quickly for the amount of space that they take up. But it seems to hold the same laws of physics, from subatomic to organic, inorganic, and then the supermassive, or the massive and the supermassive. Subatomic, cellular, planetary, galaxy, groups of galaxies. It's all the same physics here. It's all the same patterns going on. And this is why I have issues with the redshift. It is so massive that the amount of energy would be nearly infinitesimal. It doesn't make sense with everything we've known about physics so far. In order to continuously push all known stars away from each other at insurmountable accelerating speeds. So, what if, just like everything else from the subatomic to the supercluster galaxies, what if our universe is spinning ever so slowly? And what if it is a closed system, like everything else, a bubble, as it were? Sure, we could go with the snow globe as I started with. But, you know, I want to have a little fun with this. So, I think it would be funny and exceedingly ironic if the shape of the universe ended up being a boob. Okay, hear me out. I think it would be ironic for the fact that the human race, the only known intelligent creatures that are self-conscious currently, that we have been able to determine, who is obsessed with boobs, who called our own galaxy the Milky Way. Not, well, sure, because it's like when they looked into space, they saw the white, cloudy, river-like structure and likened it to milk. But humans being obsessed with boobs and milk, and boobs being symbolic for fertility and for nutrients. A swirling of new nutrients. Yeah, I think it would just be ironic and hilarious. And it would also fit a little bit with the, well, it's spherical. And it can morph based upon its motion and its spin. Okay. Boobverse. Yes. That's what we're calling it. We're calling it the Boobaverse or Boobyverse. But there's still problems that I have with this theory and with some other theories. But I wanted to go with this thought experiment just to look at things and see how ridiculous things are. So I came up with that. All right. Next, though, black holes. Black holes. Oh, I need to readjust. Black holes seem to form when massive amounts of matter comes into one place. Now, this always bothered me because of conservation of matter and energy. How are you going to have infinite density? That just doesn't align with all the known physics at all. And then I saw a video proposing of the idea of white holes which eject matter. And that could make sense, because if a black hole is sucking everything up, including light, and the amount of radiation it produces in return does not match the amount of energy that went in, then where does all that extra energy go? The idea of the expanse of the universe and of this infinite density just does not align with all these other laws of physics we've covered. So what if black holes are a point at which matter becomes too much pressure, it blows up, and in its wake, much like an explosion from TNT, which blows away the air, causes a thunderclap when the air comes back to fill in the void, or like lightning does, which is even more thunderous. What if a black hole, when these giant masses come together and explode, sending out a gravity wave that we can detect even here on Earth so far away, albeit we can't feel the effects because it's so small, but like, what if it blows up and it leaves behind this void that has to be filled? In other words, it becomes a low pressure area, just like after a bomb blows up. And as a result, it basically becomes a drain. It's like puncturing a balloon from the inside. But it's not enough of a hole to empty the contents entirely. But I think there's more to it than that. I don't know. I'll be honest. The whole aspect of black holes is still a conundrum to me. Trying to think of it as literally anything that we currently know in physics, or how things work. But what if this mass flows into either another universe or another part of our universe, and is expelled through a white hole, which is just, it's all the light. It would look white because of all the light coming in through at once, which could form another, universe, or just send more back into our own universe and collide it with each other to keep the cycle going in a new form. I bring up another universe in this case because I've seen a video that mathematics seems to prove that there should be a negative version of our universe. And if you were able to go faster than the speed of light, you might be able to pass the point into the negative verse. This would be interesting. It would also be more interesting if perhaps the black hole emptied into the negativeverse. But yet even more interesting if the negativeverse is the opposite of our universe. So where our entropy is stale, unmoving, our entropy is their rebirth. And their entropy is our high energy. Yeah, that's not easy to wrap your head around. I mean, maybe there's a few people who can, but that completely goes against everything we know of physics for our universe. Because it's literally the opposite. And how could that be something that works? Well, there's antimatter, matter, antimatter, energy, perhaps anti-energy. What if the fine structure constant is just a constant inflow of energy into our universe? And in the negative verse, there is a negative fine structure constant, which constantly steals energy. Then maybe the two universes are combined or connected, kind of like a magnetic, or like magnetic poles. And we're in a universe that is positively charged, but there's a universe that is negatively charged, and they can flow between each other depending on the states. Alright. That's very theoretical. I'm still not sure I like that explanation, but this is expanding onto my original theory. Beyond what it was before. It's just been a slow progression. Interestingly, my theory actually started as a simulation theory. Before I really knew anything about the common simulation theory, one night I was just tired and thinking like I usually do. And I did a little thought experiment where I considered, what if we are living in a simulation where we're either criminals or crazy people in an asylum who have been put into a machine to live in this exaggerated, detailed, maybe not exaggerated, but definitely detailed, simulated world where we are tasked with reaching enlightenment in order to be brought back out of this system and reintegrated into society. As if this is their way of rehabilitating us to fit in with society, because they don't want people who don't fit in with society in their society. Now, how would this be explained? Well, let's okay, I'm not going to go and just give you the original theory. I'm going to give you the expanded one that I came up with recently. So it's similar enough. That was the main premise, but the rest of this still works. That don't worry, it'll make sense. So, what do we have? In the I'm going to use the Bible as a starting point just because I find it really interesting how its days of creation match game development. So, in the beginning, God saw the world was dark and void. Alright, so you boot up your Unity project. What do you see? Void everywhere. So what's the first thing you do? Day 1. Light and dark cycle. You play with your light source first. You want to see what it does. Alright. Day 2. You separate the skies from the some call it waters, some call it the expanse, whatever you want to call it. Okay, he made a rectangle or a square. He put an object on top and separated the sky zone from his work zone. He's got his canvas up, okay? Okay. Day 3. Day 3, you add what was it? Land. The land, water, seas, and plant life. Alright, yeah. So he drew his canvas. Now he's making the terrain of the world, procedurally generated, probably. Maybe not. Could be 3D, whatever. But there you go. He made the land with water, the liquid, and then plant life. Well, plant life is pretty simple to make. There's no AI involved. It's just, tie it there, and then you're gonna want to test your lighting and your rendering system with the plants. Yes, okay. And we're gonna get into that for day 4. Day 4. The sun, the moon, and the stars. Alright, so we add a reason for the day-night cycle to exist while simultaneously giving ourselves a reason and a way to test our lighting system more thoroughly. With the, make sure all the rendering works proper. Make sure the shaders work. Day 5. Create the birds and the fish. Alright, well, the birds and the fish are simple objects to make in a game, in simple environments. You don't have to go into much detail at the start. You can add detail later. And then day 6 created the land animals and the player created animals and a human in his own image. Yep. Alright, so he created animals which are more AI driven, more complex, and finally the player character, now that he knows what kind of scale and scale of the world he's working with. And on day 7, rest. Yeah, after that much inspiration and that much work put into it, you're gonna take a rest. It's just game dev. It sounds like a video game. Honestly, it does. Anyway. So. Once he had all that set up, he's like, alright, I got my base game ready. So he invites his friends to join. They make their players. And like, they want powers to just kind of do stuff. So he gives each of them powers. So like Zeus wanted lightning, right? And well, do I even need to say more? There you go. All the gods and mythologies we used to hear about, that we hear about what used to be, all these stories of ships coming down and the gods descending from the ships, but like they described them like swords or spears or daggers or whatever else. These shiny objects floated down in the sky. It could just be the players were given extra tools that later had to be deleted. Which brings us to the Great Flood. Almost every culture has a history or mythology surrounding a Great Flood. Things where everything got deleted before coming back. Now, there's two things with this that I want to bring up. Now, carbon dating is a tool that's used to very accurately determine an object's age based on how much carbon decay has occurred. However, there are some problems with carbon dating, mainly in that when water encompasses an object, carbon decays faster. So by putting water on things, it makes it seem to age faster. The Great Flood. What if, because of the power creep that came upon all these players coming in and asking for powers and stuff, some corruption happened? And so, while it was described as a flood, it was really just corrupted files that had to be deleted and edited to try and restore as much as he could. And this would explain why one of the main issues with carbon dating is things are pretty accurate up until about the time of the flood that is predicted. And after that, things seem to get wildly aged, almost way too aged. Now, in a computer for programming, if you have to delete your files and recreate them, then, but not all of them, then a lot of them are going to show, the age of when they were recreated, which is after the deletion happened. But the other ones are going to show older. But, interesting. Alright. Next. He invited friends again to come back on. We got our gods, we got our mythologies, our heroes, all this stuff. Now, here's the thing. I know people are creative, but people aren't that creative. Like, yeah, okay, sure. Every now and then you will have someone who can just create these fantastical things. But honestly, a lot of times, more times than not, these people still draw from stories of the past and just alter them. Now, also, sure, some of these stories of mythological gods, maybe the stories got exaggerated over time because the storytellers wanted to make it more exciting, while other stories got watered down over time, so we don't get to hear as much of what happened. But like, a lot of the stories, especially with the Roman gods and the Norse gods, a lot of those stories just feel like they're based on some kind of events that actually happened. And it's weird just how much detail goes into a lot of those stories. But, it could just be a coincidence, whatever. But, So, eventually, God decided he'd pick it, everybody had their own people. God had the Israelites that he picked as his people to bring about and raise. And then he got an idea. He wanted, well, not only did he want his son to join the game just for fun, but he wanted to see how people would grow. He decided to pull a social experiment with his game, which look, how many of us, if we were able to make a game like this, or like The Sims, would totally pull social experiments if we thought we could get away with it? Yeah, I know what some of you do with those Sims, okay? Anyway, point is, either he kept the game for himself, or maybe he gave everyone their own copy, and then he saved one aside just for himself. We still have the old history of where all the other players were, but they're not here anymore. We don't have all these stories of gods anymore, all these wacky tales of heroics and all that. What if that's because he took, because of this disconnection from all the other players, and now it's just God trying to do this social experiment, just checking in every now and then, but not really interacting anymore. But even from all of this, before all of this, the players would have caused enough ruckus that it could explain several things. One, obviously the stories, but two, what if the players told the NPCs about their life in another, or in the outside world, and the NPCs interpreted this as maybe they themselves could go into the outside world. Maybe if they just reached enlightenment. Now the theory regarding us being rehabilitation patients or whatever, that would be a lot more explanatory for the idea of enlightenment being so common in so many cultures and religions, and the idea of reincarnation as well. But if we could just go down this route instead, it's still possible that they made that interpretation and that spread as an idea that maybe if they might just die until they come back. They got that idea because the players, they would have, some of their characters would die and they'd have to make a new character and they'd just be back, reincarnated essentially as a respawn. And the people were excited to see this. Wouldn't that just be interesting? Anyway, so we're just left with remnants of what was, stories passed down of what was, as now things just seem a lot more boring and mundane and predictable. But then I want to go ahead and bring in this. What if Jesus coming into the game, Jesus is God's son, and he decided to expand on the social experiment his dad was running. And so many of his teachings were based on this. But he started out not like cheating the system. But then when he was 30, he started doing miracles. So what if he finally decided he was going to give them a reason to, I suppose, believe? What if? I'm so sorry about the sound of the mower. Hopefully you can still hear me. As said, this is unscripted, unedited. This is just raw thinking. I want you guys to be able to follow along in my thought processes as best as possible without any cuts or edits. Anyway, point is, at age 30, he went ahead and added some of the mods or extra powers that were possible to just do things for fun. Well, sort of fun. And then after he was killed, he came back just to show, yeah guys, reincarnation, totally possible. Enlightenment, totally possible. Now, I don't know if this would go for an actual enlightenment to be able to happen, but it'd be interesting. Also, the reincarnation thing would be also explained in another way by the point of it's just reused code. If an NPC dies, their code gets reused and recycled back into a new NPC. This could be another reason why so many people through time can look like each other. Like Rorschach. I had a friend in high school and college who, well, when I learned about Rorschach, the guy who made the ink blots, I saw a picture of him and I was like, dude, that's you, dude. He looked exactly like my friend. It was nuts. It was so nuts. I couldn't believe it. I showed him, I showed some other people, and they all like, they could be the same person. And then there's just other people who seem to. I think I've seen some other people who people have pointed out. Just what was it, Christopher Reeves? There's been people throughout history that looks like Christopher Reeves. Insanely so, to the point that there was like a theory that he's some kind of immortal and he just keeps changing his profession and everything to keep having fun with life and like distract anyone from noticing that he's immortal. So like I guess if he ends up like just stops acting soon, we'll know he's gone into hiding it because of that, maybe. I don't know. It's interesting to think about that though. But there's so many things about our stories and our mythos that would be explained if the world was a simulation. And then combine that with what I was bringing up earlier, that a lot of the fundamentals of the universe seem to be based around the kind of concept of how we program, using the constant variables, the floats, the integers, the booleans of true-false statements for the conditionings. Oh, dang it. I forgot to bring something up that I really wanted to bring up. Like, I've been playing around, toying with ChatGPT, walking it through my theory because I wanted to hear what it had to say and if it could, like, just poke holes in my theories. But I guess it was more in idea mode, wanting me to build the universe further. So it wasn't quite as helpful, but it did occasionally bring up new information that led me into areas I could research that I didn't even know needed to be researched to help form some of my theory. But one of the things that I kept forgetting to bring up in that, because it just didn't seem to work, and I forgot to bring up here, is the thermodynamics of matter also matters for the properties of elements. Which, I mean, this could be explained. Well, this could be explained by their behavior changing based on how much energy they have. Which I said that their behavior is by motion, spin, and charge, but it's also energy. Charge itself is not necessarily energy. But there's been this other thing that really bothers me about how we see the world. Most people like to box everything up into black and white boxes with edges, but like everything I've seen, everything I've explained so far seems to correlate to a fluidity, where everything is explained in a fluid way, everything interacts as a fluid of sorts, that there's really no straight cut off from one thing to the next. It's more like everything is connected, but it's all dependent on move and spin and charge and temperature. So why I want to bring this up. If you super cool a gas like hydrogen, it begins to act like a liquid at a certain point. If you superheat gas, it acts like a plasma. If you super cool a solid, first you can hold on. I forget. I think I'm messing something up here. I haven't looked into the whole liquid hydrogen. I thought, no, liquid hydrogen sounds right. Oh, right. Yeah. Okay, I know what I'm doing wrong. All right. So we have the 4 stages of matter. There's probably another one, at least. Maybe 2 more, I'm not sure. But we have solid, where mass is tightly enclosed. It doesn't vibrate very much. There's low energy. It doesn't have much room to move. And the low energy mostly is why. You have your solid, you have your liquid, you have your gas, and you have your plasma. Hydrogen, if you supercool it enough, can act like a liquid. If you go up the periodic table, where there's more mass involved, it's easier to change which form of matter they represent. For instance, mercury at room temperature can act as a liquid. And then it's easy to solidify it as the metal. But again, if you superheat it, I believe it can become a gas. I could be wrong. But my point here is anything cold enough can lower which stage of matter it represents And if you heat it enough, you can increase which state of matter it's in. Where the lowest state, like the lowest state charge or energy in an electron, is closest to the atom. So is solid closest to the atom. And then you have your liquid, which is a little further apart. It has a lot more room to move around, bounce around. Then you have your gas, which has a lot of room. And then you have your plasma, which there's so much room between them. Yeah, I don't know if there's another state of matter or whatever, but my point here is, these stages of matter are not necessarily fixed points in energy. Like, they'll decidedly show or act mostly like a certain type of matter depending on exact temperature, sure. But, like, let's take water for instance. Water, which is, two hydrogen, one oxygen combined, and then just lots of those moving about, bouncing around in a liquid, room temperature. They move around a lot. If you take away that heat, that energy, they start to become less bouncy, less fluid, until eventually they freeze into a solid. And then, if you instead add heat and energy into it, they bounce around more, and then you get your boiling, where they split into gas. And then it becomes water vapor, but it's still water. It's still the two hydrogen and one oxygen. But it gives so much room between one molecule to the next that they escape each other and go out into the air because they just have so much energy. And this seems to play a part again into the constants. All, I guess, supposedly dictated by the fine structure constant, which is what holds, mostly determines how things hold together. Combined with the gravitational force and the strong or weak force. Anyway, so there we go. What if our universe is a snow globe? What if it is a boob? What if we're in a simulation? Yeah, I definitely missed a lot of things. I probably should have scripted this. I could have covered so many more details because there's so much more that goes into this. Like, I could connect, to an extent, I could connect economics into this, a lot more psychology, a lot more theology if I went into detail. I don't know about art, but yeah, there's so much more. But I think that gives a good enough rundown of my theories and why I believe the current accepted rules just don't quite work and vibe and mesh with the currently known laws of physics. That there must be something else. There just has to be. Like, I believe the simplest solution to what we're observing is that the universe, our universe, is rotating, which would explain the redshift. It would explain a lot more phenomena in general that we've been seeing while looking stuff up yesterday, while talking with ChatGPT. I came upon the Hubble crisis, they call it. This would explain the this would resolve the Hubble crisis. Then I found out that as I was saying my theory, I actually looked up literally last night and found that there actually is an article that came out recently showing a mathematical model that the universe spinning would explain a lot of things. And I was like, hey, perfect timing. Of course, it's not new. This used to be something that was considered. And then for whatever reason, they decided that infinite energy and infinite density makes way more sense somehow, even though that definitely does not explain... even though that doesn't make any sense for any of our other laws of science. And like, you could bring psychology and sociology into this because everything is physics. Like, literally everything is physics. Okay, people act in a similar way to physics. Some time back, while I was working a job that just kept me so busy I couldn't really live life, I decided to go into a war mobile game, to do social experiments, because I needed something to keep my mind busy and distracted, since I didn't have enough time to do what I would normally do. Because I was just on the road all the time. I was away from my house. I was just... Yeah, anyway. So, in these social experiments, I paid attention to how individuals interacted with other individuals in a situation where, well, it is a war game. In a situation where resources are limited, the game is designed to hoard resources. And then I paid attention to how an alliance is formed, and how the groups and alliances broke up. I paid attention to how people resolved problems, how people resolved, well, I guess fights just in general. I paid attention to why people fought. And overall, I found people, to an extent, sort of act a lot like electrons, because based on their type of charge, emotional charge, we're going to liken this to quarks, because quarks have like 6 different states depending on their rotation, but people are a little more complicated. There's a lot more emotions, but based on one mentality, which we're going to liken to the atom, because mentality, like the atom, determines behavior based on which mentality or how many protons. Okay. I found that people of similar energy, similar mentalities, were way more likely to group up together. Which is interesting. And then, with these groups, they would look out for each other and try to grow each other as a group. However, some of these groups of people, there's this mentality involved where they're still self-seeking, which is kind of like, um, which one was it? Dang it, I forget which one it is. I forget which side of the table of elements it is. But the side of the table of elements that is more likely to take electrons than to give electrons. This one is what I like in these mentalities too. Because, yeah, they'll join a group, but oh no, you know what? No, it's more like the electrons that are way more likely to leave. No, it's based on atoms though. Okay, whatever. Point is, these people, yeah, they'll join a group, but they will also easily leave, and they'll take everything they can on their way out. Like, I had this guy who, I told him how I automated part of the game so he could automate part of the game and, benefit from it. But then, like, when he told other people about this process, he claimed all the credit for it. And then, despite our conversations and having worked as a team for a while, he and his girl decided to go to another server, and on their way out, they just attacked me and everybody else, stealing as much gold as they could on their way out, as if burning bridges. No sense of loyalty, only self-satisfaction, and they'll join groups just for their own benefit until those groups do not benefit them. Now, sure, most people are like this. Well, maybe not most, but a lot of people are like this. And it all depends on the mentality, the charge of the person. So that's why I liken it to electrons in this way, or atoms and electrons. It's kind of both in some aspects. Anyway, what else? I also noticed, there were some people like myself who would take up a sort of guardianship of the people who have less energy, the people who put in less effort. While we ourselves put in a lot of effort, we like to take care of the people who don't, because we understand everyone has a life. The game is not their life. And so anyone who attacks this group, we will attack back. And we will protect. I noticed a lot of interesting things about each type of group of people, but I'm not going to get into all of that. My point here is to liken it to physics in that regard. At least for the time being. Although with one of my friends, decided he wanted to get on one of the new servers and test how fast he could power up without spending any money at all, because the new servers had a lot more advantages. And wow, did they ever. I decided to join him on this as a little bit of a competition, which I ended up having some days off of work during this time, so I actually had an advantage. But honestly, I think he did better. I think he did better at it overall for what time he put in. But in this, I did another social experiment. So I found very interesting, and is going to lead into connecting some things, a lot of things, when I get into this. All right, I'll go ahead and go with this. So there was this item in the game where if you use it, it changes your gender icon from male to female. There's no other changes. Everybody starts off as male unless you use this item. Now, I wanted to see if you use this item, that you get another one that changes it back, just in case, you made a mistake or something. But they didn't. So now this new account on this new server, which didn't end up on the same server as my friend, just showed a female icon. So I decided, alright, I'm just going to be spending 1 week on this account. I'm going to do something crazy for a social experiment. I decided to not once state my gender, and I wanted to see if people could tell that I was male, or if they would think I was female, strictly because of this one singular icon. And while I was doing this, I also took up a secondary social experiment where I became the most unhinged, the most, what do you call it? The most goal-oriented, goal-driven, the most horny, the most energetic, the most basic version of myself. All the things that I would normally filter off to let myself in this experiment just be myself without the social expectations of any kind. And what I found was, yeah, a lot of people kind of thought I was a girl just because of the icon. But I think there were reservations. I was very confident in everything that I did. After all, I played the game for quite a while beforehand. I knew what I was doing in the game, so I could explain it to all the new people, and they'd just see it as like magic or something. So they would learn. I added a huge amount of energy into the group, into chatting with people. And with that energy, a lot of people likened to follow me. But I was not the leader. I didn't want to be the leader. I hate being a leader because I hate having the responsibility, the expected responsibility of taking care of everyone, but I'll take care of the people around me regardless. It's just, I don't want to lead. I want to, support in leading, I guess. Even though a lot of people would kept trying to push me to lead anyway. But that's beside the point. My point here is, I found some very interesting things. One, women loved it. Gay guys seem to love it. No, not gay, sorry. More feminine guys loved it. Loved this caricature. But especially women loved it. Men, on the other hand, were taken aback. Yeah, some of them tried to flirt,
messaged more. I sure got a lot more friend requests and a lot more DMs than I ever do normally. And I gotta say, I'm so glad I don't get that anymore. I can now sympathize with women. Just go anywhere and you get so many messages. It's not even funny. It's so ridiculously annoying. Like, I just want to play the game in peace, okay? But in this social experiment, I was not just playing the game in peace, but, that's beside the point. My point is, wow. um, oh, God. Where was I? Guys were taken aback. It's almost like they wanted, it's like I could feel this weird tension that, like, some guys kind of wanted to interact, but they were scared to because I was so confident and maybe aggressive. I don't know what you would call it. I guess you could call it aggressive. But, like, I think over the course of time, though, like, more of them seem to avoid me, and I'm kind of wondering if some of them realized or started to suspect that I was not a girl. And it wasn't until later that, like, I was talking with some of the girls I had friended in this, since the only rule I had was to not state my gender, I did not hide anything else. So, like, there was a point where I took a picture of something to show one of my friends, and in the picture she saw a reflection of my fingers, which told her that I was a guy. Now, when she found out, she loved this because she was glad, because she's not into women. But in this revelation, she told me that she heavily suspected that I was a dude because of the way I talk, because of the word choices I use, because of how I talked. It just sounded more masculine. Now, I don't know what exact words and phrases I used. She didn't tell me, but this was interesting to me. And then there was another girl who, I showed her my Steam account so we could, like, play together or whatever, and, like, she saw that I was a dude there, and so she brought it up. But she still kept talking with me after, because, even with the concern of, dude, you've been lying to me this whole time. But, like, we talked, and she's like, well, I suspected you were a guy, but, it's the way you talked, some of the things you said, and so on. And that's what I was looking for. How can you tell? Now, in all of these social experiments and combining it into my theory on the universe, everything seemed to point to very interesting thing, that people act a lot like physics. Societies act a lot like physics, where high pressure flows to low pressure, where high energy flows to low energy, where you'll have these bubbles of groups, and then if it gets too much, it explodes or collapses, depending on how much it explodes. Well, how much is there. And it got me thinking of life in an interesting way. So, like, I've touched a little bit on this. I'm finding it really odd that entropy has not happened yet. Like the example of the isotope of gold. Like it's like things are setting to a stable environment, but no matter how much energy is there and not there, where energy is constantly trying to move to low energy and transferring and all that, freaking, we're still not at entropy. Why are these bubbles, these atoms, these planets, these galaxies still surviving and thriving, essentially? Why are there so many pockets of energy that still exist, that hasn't dissipated into nothingness? Why is it that economy, despite some economies crashing and collapsing, economy still flows regardless? Why is it that people keep existing even though there's so many things that are killing people? So many wars, famines, etc. It's interesting to me. And I've come up with this visualization that utilizes a scene from National Treasure, where they're in this hole where the ground has given way, and there's this wooden plank on where the middle of the plank is on a stone, and all of the people have to balance on it as it's rotating around this point and adjust their weight constantly in order to get each of them off safely. And they do it in such a remarkable and interesting fashion. I love it. That scene was great. But now I envision the universe as being symbolic with this a little bit, in that it's like many planks of their own types. You have your life, your death. Your life on one side, death on another. You have your high energy on one side, low energy on another. High charge, low charge, high pressure, low pressure. It's like everything in the world, everything in our universe is in this constant teeter-totter, this constant balancing act between entropy and energy. And when a system looks like it's going into entropy, somehow something happens that balances it out and swings the other way, as if a pendulum swing, where now there's energy. And then if there's too much energy, then that explodes into negative energy, which could be, black holes. It literally, too much energy explodes into negative energy as a pendulum swing, so to speak, to counteract. Yeah, I don't know. The point is, it's like that, and like these planks of life, of all these different aspects of life, are just constantly rotating and constantly going up and down based on the forces. And people fit this as well, because the main reason I even thought about this is I have a really hard time balancing my life. And when I do find ways to balance my life, something inevitably happens to stop it from being balanced. It's like the laws of the universe and the laws of life work together purposefully to destroy any form of balance and staleness. It's so weird, because it's like, have you ever had a time where you're like, all right, finally, I've got all these bills paid, I've got all this taken care of, I've got all this set in motion, now I could finally live peacefully, and then bang, something breaks down, or bang, someone dies, or bang, someone decides to move across, or your best friend decides, no, maybe not your best friend, but somebody important in your life decides to move across to another country, and whatever it is, something happens, and it throws off the balance of your life. And it's just like a constant upheaval to evade entropy, to evade comfortability, as if no one is allowed to be and stay comfortable. And the only people who sort of enjoy any form of comfortability have to do so by taking advantage of other people, by taking their energy and, well, most I don't know. I'm not gonna get into that one right now. But I'm sure there's a connection. I just don't know where to go with it. I haven't thought about it, and I don't want to at the moment. I'll think about that later, when I'm not recording, because that's gonna be that would be a huge rabbit hole, and it probably is gonna link to like the atoms and electrons again in some form. Regardless, it's like everything is in a constant motion of a balancing act, and somehow, some way, entropy just never comes. It never arrives like you think it should. And this seems to be true for just society, for people, so for psychology, for physics, from the subatomic level to the highest level. And all the different laws of the universe that we see, it also seems to apply to this, almost as if there's a constant stream of energy flowing in from seemingly nowhere to constantly keep things interesting, to keep things from being completely dull. And I guess I'll leave with this. Something I thought of so long ago now. I don't even remember when I thought about it. But Newton's law of motion, the one about for every action there's an equal and opposite reaction. At some point, I realized this, and I'll definitely just leave you off with this. That seems to apply not to just physics, but it seems to apply to people's behavior too. For every action, there's an equal and opposite reaction. You tell a funny joke, and some people will laugh. Maybe it's just you, but there will be also somebody who gets angry, has an opposite reaction. You do something nice for someone, okay, then yeah, that's great. But then there's the opposite reaction where it either ends up causing harm, or you didn't account for something, so something got worse, or someone hated that you helped them. So there's an opposite reaction. Like, you'd think helping would be rewarded more, but a lot of times it seems to do just as much bad sometimes. No good deed goes unpunished is a phrase that I've heard a lot. And when I made this connection for physics, probably connecting with this, and then I heard that phrase, it just made way too much sense. So, anyway, that's all for now. Maybe I'll make another video exploring even more on a deep dive Because I haven't even touched a lot of the different fields that I want to go into. There's so many things in life that mirror each other in ways that is insane, and I don't see people bringing these up. But that's probably because I'm just the really weird one who I like to I just like to try to understand life at its most basic levels, and I've just been taking in observations over time, trying to form something that resembles truth. And most people, let's be honest, most people don't like truth. Most people like their boxes of understanding. Most people like being where they are and staying there. They avoid truth at all costs. They say they like truth, but when it comes down to it, they avoid it like the plague. Anyway, signing off.
Ciao.